let's look at some of the questions from our semester exam review. Here in this first section, we're reviewing angles in the unit circle. And in question number 1, we're asked to draw the following angles in a coordinate plane and then determine the reference angle. So our first one is 190 degrees. I noticed that this is a positive angle. And so when we draw this in the coordinate plane, we're going to start over here on the positive x-axis. And for a positive angle, we're going to move in a counterclockwise direction. So I'm going to start here and go to 90, 180, and just a little bit past 180, that's where we would hit 190 degrees, including my little direction arrow here to show that we went in the positive direction. Now I also need to find the reference angle. The reference angle is going to be the angle between the terminal side and the x-axis. Or in other words, how far away are we from the x-axis if we're at 190 degrees? Well, that reference angle is going to be this little angle right here. And we can find it by subtracting 190 minus 180, which gives me a reference angle of 10 degrees. All right, let's move on to question B. Here in B, we've got a negative angle, negative 105 degrees. So I'm going to start on the positive x-axis again, but this time we're going to move in the clockwise direction. And so if I head around this way, I'm at negative 90, and then negative 105, just going to be a little bit past negative 90. So again, terminating here in the third quadrant. Now my reference angle, remember, is going to be the angle between the terminal side and the x-axis. Always measure your reference angle to the x-axis, never to the y. So in this case, my reference angle is going to be this angle here. And that angle is going to be the difference between 180 degrees and 105 degrees, which gives me a 75-degree reference angle. Let's move on to C. Here in C, we're switching to radians, and we've got a positive angle, 6 pi over 5 radians. So we're going to start at the positive x-axis and move in the clockwise direction. When you're working with radians, it's really helpful to remember the radians that mark each of the ends of the axes, just to kind of give us a frame of reference for these fractions. So let's remember that here at 90 degrees, that's going to be pi over 2 radians, or 1/2 pi. At 180 degrees, we have pi radians, and at 270, we're at 3 pi over 2 radians, and if we make it all the way around the circle, then we're going to hit 2 pi. So 6 pi over 5, if I think about that, 6 over 5 is just a little bit bigger than 1. And so that means that my angle is going to start here, move in the positive direction to 1 pi, and then go just a little bit past that, terminating again in the third quadrant. And my reference angle is going to be the angle between the terminal side and the x-axis, so this angle here. And we can find that by subtracting pi from 6 pi over 5. So 6 pi over 5 minus 1 pi, or if I get a common denominator, we could make that 5 pi over 5, which would be 1 pi. And 6 pi over 5 minus 5 pi over 5 gives me pi over 5 as a reference angle. Last question, negative 10 pi over 3. Negative 10 pi over 3. So this angle is a relatively big angle. If you think about that fraction, it's actually bigger than 2 pi. 10 pi over 3 is going to be bigger than 2 pi. And so I'm going to draw our coordinate plane. Again, we're going to be starting on the positive x-axis. We're going to move in the negative or clockwise direction. And I know that I'm going to have to go all the way around to 2 pi, which if we change that to thirds would be 6 thirds. 2 pi over 3. 2 pi is the same as 6 pi over 3. Just write that out here to help us. It's the same as 6 pi over 3. If I keep going all the way to here, this would be well, going all the way around and then adding this on would be the equivalent of negative 3 pi, which is the same as negative 9 pi over 3. And so I'm almost to that 10 pi over 3. I need to go 1 pi over 3 more, which would put my angle terminating here in quadrant 2, with our direction arrow showing that we went in the negative direction. So this would be our angle, negative 10 pi over 3. Now we need to find the reference angle, which is going to be the angle between the terminal side and the x-axis right here. And if you remember, once we made it all the way around to here, we were at 9 pi over 3. And so after that point, we went another 1 pi over 3, and that's actually going to be our reference angle. Pi over 3 or 1 pi over 3. All right, let's look at the next question. Here in number 2, we're asked to convert the following angle measures from degrees to radians, leaving our answers in exact simplified form, and we can use a calculator. So when we're converting from degrees to radians, we need to remember that conversion is pi equal to 180 degrees, or some of you may still be using 2 pi equal to 360 degrees. Either one of those is going to result in the same answer. I'm going to use pi equal to 180. And when we set this up to convert, we just need to be sure to arrange our fraction in the way that we need to end up with radians. I'm going to have pi on the top and 180 degrees on the bottom, because I want degrees on the top and degrees on the bottom to cancel out. I want those degree units to cancel out and leave me with radians. And so I end up with 215 pi over 180. Now a graphing calculator is allowed. However, if you type this in the calculator as it is, you're going to end up with a decimal, which is not going to be an exact answer. In order to use your calculator, we need to only enter in this fraction part, and just let the calculator help you with simplifying that fraction. And so if we do that, we're going to end up with 43 pi over 36. The calculator will give you the 43 over 36, and then we can put the pi back on our answer. So negative 460 degrees, we're going to go through the same process here, multiplying by pi over 180 degrees. We've got degrees on the top and on the bottom, so they can cancel out. And I get negative 460 pi over 180, which would simplify to negative 23 pi over 9. Moving on to question number 3. In this question, we're asked to find a positive and a negative coterminal angle for each of the angles that are given below. Now remember, coterminal angles, those are two angles that have different measures but terminate in the same place. So let's think about, first of all, this angle 280 degrees. I'm just going to draw a picture on this one to remind us what this coterminal means. 280 degrees, that is bigger than 90, bigger than 180, just a little bit bigger than 270. So that angle right there would be 280 degrees. One coterminal angle that I could find would be to start here at the positive x-axis but work in the negative direction, terminating in the same place. And the measure of that angle, I could do 360 minus 280. And that would give me 80 degrees, and it's in the negative direction, so negative 80 degrees. 280 degrees minus 360 gives us negative 180. Negative 80 degrees. That would be our negative coterminal angle. We also need a positive coterminal angle, and the way that we get that is by starting here on the positive x-axis and going all the way around 360 degrees, and then again going around until we terminate in the same place as our original angle. The measure of that angle is going to be 280 degrees plus 360 degrees. And that's going to give us 640 degrees. So really, with coterminal angles, the main thing that we need to remember when we're in degrees is that to find a coterminal angle, we can either subtract 360 degrees or we can add 360 degrees. That's what's going to give us a coterminal angle. So let's move on to B. We have negative 110 degrees. I can do negative 110 degrees plus 360 degrees, and that's going to give me a positive coterminal angle of 250 degrees. I can also do negative 110 degrees minus 360 degrees. That gives me a negative coterminal angle of negative 470 degrees. Now when we're working in radians, the idea is very similar, except instead of adding or subtracting 360 degrees, we're going to add or subtract 2 pi. So I'm going to start with adding 2 pi, 7 pi over 9 plus 2 pi. Now in order to do this, we need to get a common denominator because I'm adding with fractions here. So this is going to become 7 pi over 9 plus, instead of 2 pi, we need to make that over 9, so it's going to be 18, because 18 over 9 would give us 2. So 7 pi over 9 plus 18 pi over 9 gives us 25 pi over 9. So that would be a positive coterminal angle. And then we can also do a negative coterminal angle by doing 7 pi over 9 minus 2 pi, or I'm going to write it as minus 18 pi over 9. And this would equal negative 11 pi over 9. All right, our last question on this section, negative 3 pi over 4. We're going to do negative 3 pi over 4 plus 2 pi. But this time I need my 2 pi to have a denominator of 4. So if I change that to a denominator of 4, my numerator needs to be 8 pi, because 8 over 4 would be 2. So negative 3 pi over 4 plus 8 pi over 4 gives me 5 pi over 4 as a coterminal angle. And then I can also do negative 3 pi over 4 minus 8 pi over 4. And that's going to be equal to negative 11 pi over 4. All right, finally, the last question for this video. We're asked to give the exact values for each of the following. And this question is really testing your knowledge of the unit circle and how well you remember the sine and cosine values of those unit circle angles. What's going to be really helpful here is knowing the first quadrant very well, and then being able to figure out what quadrant the particular angle is in and whether or not the sine or cosine should be positive or negative. So let's start with cosine of 2 pi over 3. If I think about the first quadrant in the pi over 3 angle, the cosine value at pi over 3 is 1/2. Now 2 pi over 3, that angle is in quadrant 2. And in quadrant 2, cosine is negative. So my answer here should be negative 1/2. Sine of 5 pi over 4. Again, if I start with the first quadrant angle, pi over 4, sine of that angle is square root of 2 over 2. And now if I think about the angle 5 pi over 4, that is an angle in quadrant 3. And in quadrant 3, sine is negative. So this is going to be negative square root of 2 over 2. All right, question C, cosine of pi. Now pi, that's one of my axis angles. That's the angle over at the negative x-axis. And keeping in mind that cosine is the x-coordinate, if I'm on my unit circle out on the negative x-axis, then I'm going to be out there at negative 1 for my x-coordinate. Cosine pi is negative 1. Sine of pi, since we are on the x-axis, the sine or the y-coordinate is going to be 0. Sine of 7 pi over 6. So again, if I think about pi over 6, in quadrant 1, the sine value at that angle is 1/2. And then 7 pi over 6, that would be an angle in the third quadrant where sine should be negative. Question F, cosine of pi over 2. Pi over 2 is, of course, on the positive y-axis. And since cosine is the x-coordinate, its value will be 0. Question G, cosine of 3 pi over 2. 3 pi over 2, that's the negative y-axis. And since cosine is the x-coordinate, then again our value here is 0. Sine of 4 pi over 3. So for pi over 3 in quadrant 1, the sine or y-coordinate is square root of 3 over 2. And 4 pi over 3 is an angle in the third quadrant where sine is negative. Finally, sine of 0. Now 0 is the angle that's at the positive x-axis, and sine is the y-coordinate, and so therefore would be equal to 0.